I'm Donald Kessler. I'm retired from NASA's orbital debris senior scientist.
And your work.
It was, first of all, identifying the orbital debris issue and saying that this was convincing my management that this was what needed to be done. We needed to do a lot of rules that would keep the debris from continuing to increase. And and at that time there wasn't even a program. So I was asking for there to be a program. And so they established the program, put me in charge of it as the chief scientist, and then come up with recommendations of what they should do in order to minimize debris. And some of those were things as simple as whatever you launch into orbit, it has to come down within 2 years of after you've used it. And that just means you carry up an extra amount of fuel such that when you're through using it, you use that fuel to reboost it back down into the Earth orbit. And that turned out to be fairly successful until we learned about there are some satellites that are blowing up and nobody has done anything there's no reason they should be blowing up until they realize, oh, we have a leak in this rocket body, and if excess fuel eventually, it may take a year or two, reach the oxidizer, and all of a sudden they blow up. And so we need to quit doing that. And so there were things that they ended up slowly learning, that there were things that they could do that they could at least slow down the process. And of course, the leading thing was to minimize the amount of stuff that you leave in Earth orbit. And that turned out to be the key to at least slowing down the growth, but it didn't stop it. It wasn't sufficient. It had got to the point that the debris would continue to increase, and it's still continuing to increase today. Because we're launching satellites, every time they especially when they build a constellation of satellites, they put a bunch of small satellites in a small area, and eventually, even when they run out of fuel, they become randomly they'll go in different directions eventually because of just the way the gravity affects them. And they'll run into each other or run into somebody else, run into another satellite. So the story continues to say we don't have a solution to this. It's still getting worse.
And when you're talking about the constellations, you're talking about something like similar to what SpaceX is doing with the Starlink satellites.
Yes. There's those kind of constellations that will group the satellites into a small area, and you'd think that it's pretty stable, but it's really not, and it doesn't take much variation in the altitude to change the forces, and they eventually will cause a problem too. It's just it becomes a matter of, well, how can we slow it down enough that it'll take a long time to get worse.
Yeah, and so I think that SpaceX has a way to control them, so they actually decommission those satellites after 5 years.
Yes, in fact, we started doing that. That was just sort of a rule that we established a long time ago, that you do not leave anything in space. You always carry enough excess fuel to bring it down after you're through it with your function.
That's good to know. And that is part of the regulations that were imposed on all the different organizations that have objects in the low Earth orbit and beyond, right?
Yes.
Okay.
Yep. And of course, you're never going to get rid of all of them, because there's some of these that are beyond above about 1,000 kilometers. You start getting up to those altitudes, there's hardly any atmospheric drag, and so they come down extremely slow. But when you go up to geosync, there's actually nothing to slow them down. Mm-hmm. And so that within geosync, they're continuing to run into each other, and of course that will scatter them out of geosync, and eventually geosync will become you won't be able to use that either.
Okay, and that's interesting, and that takes me to my next question, which is kind of a combination to talk also to Chris a little bit.
You can define an inclination, but it doesn't take much for that inclination to just sort of wobble like this. Mm-hmm. And unless they're in sync, and they all wobble at the same time, but all it takes is just a short distance to the size of it, and they'll wobble at a different rate. and it'll get scattered. They'll end up running into each other eventually.
Yeah. And your work takes into account all those variations to be able to calculate the trajectory of the objects up there,
yes.
right?
Well, I just, it was easy to assume certain things, like what you know that the effects will scatter these things eventually, slowly. So there's a fact, and if they don't scatter them, you still got the problem. Well, if there's a bunch of them in one spot, the bigger chance that they're going to hit one of them if you're going in a different direction. So all of those things tended to average out. But so what I mainly did was just looked at the statistics of you got a certain size, you got a certain amount of volume to work in, and as soon as you start causing problems. I use an analogy. If there's one car goes down the street like it is there, if there's only one, and you want to walk across the street where it is right now, you'll get hit. Mm-hmm. But if they're slowly going to each other, they're very far apart, there's a chance you can walk across the street, and even without a street light, without getting hit. Mm-hmm. But we're into the point where there's so many cars in space, effectively, that you have 100% chance of getting hit by something.
That's a very good analogy, for real. Yeah, that's great. And Chris here, Christopher Jones, wrote a book that's in front of us right now, Mars Mission 1, Surviving the Kessler Effect, which is based on the work that you did. And I wanted to ask you, Chris, what inspired you besides knowing, how did you come up with the idea that it was a good use of your time to write this fictional story based on the real science that Mr. Kessler discovered?
I wrote Mars Mission 1, Surviving the Kessler Effect, and came up with the second edition now. I was, after retiring from the fire department, I went to Kennedy Space Center, and I had time on my hands and was just doing some exploring, and I happened to see a YouTube video about the Kessler Effect, and he was rather amazing to listen to what he had to say about it. And there was a picture of Donald, in the video, and so I looked it up to find out, is this really fact or fiction? And I was on my way to the U.S. Space and Rocket facility in Huntsville, Tennessee, and or Huntsville, Alabama, and I went there and could not believe what I was seeing. It was phenomenal. And then they had some information on the Kessler Effect there, and I ended up driving out to California to go through the Tesla factory in Fremont, and so I had quite a bit of time on my hands for the drive. And I was thinking this through about the Kessler Effect, and is it real? And obviously it was. And SpaceX was at the time discussing the very realistic possibility of taking people, humans, astronauts, to Mars. And it suddenly occurred to me that, oh, wait a minute, if we have a mission on Mars and the Kessler Effect takes place, the full-blown Kessler Effect takes place, could they ever make it back? Might they be completely ostracized or left on Mars with no way home? And then I started thinking, well, what about the people on the International Space Station? I mean, these are real living astronauts, virtual heroes, and we may be leaving them behind if this ever happens. And then I thought, wait a minute, no, the International Space Station is in fairly low Earth orbit. It would probably be destroyed. And I was like, holy cow, there's people on it. So, I mean, it's like, I was overwhelmed with somebody's needs to get this message out. Mm-hmm. And I've never written a book, and I never thought I could. I've never really been good with words. But I just was like, someone needs to hear this. This message has got to get out. So the first book I just pumped out just to get the message out. And it's taken me some places. And then I was told that, Chris, the first book is great, but there's a whole lot of stuff in there that you didn't take to the full development of the concept. So over the years, Donald and I have been in conversation numerous times, and he's just done nothing but to convince me that the Kessler effect is a real world issue. What could be even more convincing than a total convention from the IAC, as they had held in Italy this year, and the entire convention was on nothing but how to preserve space, how to keep space usable. I mean, if you have every science and rocket manufacturer gathered together for the same purpose, must have some merit.
Yeah, and how did the two of you meet? How did you start sharing information?
He called me.
He called you?
I looked him up, found him on the internet. It took a while. And then I was nervous and my hands were shaking and my palms were sweaty, and I called him up and he said, hello. And I said, is this Donald Kessler? And he said, yes, it is. Who's calling? And I'm like, are you the real Donald Kessler? And he's like, yes, it is. I said, the Kessler from the Kessler Effect? And he goes, yes, it is. And I was like, oh.
So you were starstruck.
Oh, yeah.
Yeah.
Yeah, I mean, the work that Mr. Kessler has done has been important. And so after you two met, it seems like the two of you built a friendly relationship, and you have been collaborating and swapping information, and that is part of the new book? Is that kind of...
Yeah, of course, because the new book is just expounding on really the first...
Yeah.
You sent me one of your first research articles, scientific-based research articles on orbital debris. And all I did in this book really is just it's taking the first book and just, extending what actually happens when you have a loss of all satellites, loss of communication with all satellites, all the internet goes down, the entire knock-on effect of losing the internet. And we don't realize how dependent we are today on the internet. It's amazing. But imagine Wall Street without the internet.
And right now my understanding is that the actual Kessler effect or Kessler syndrome already started, yes?
Oh, yes.
It's just at what rate it progresses that will determine the impact that it will have on us humans and outside of here, right? Because we already we're communicating with devices that are out of the planet already, and maybe that communication also suffers, correct?
Right. Yes. Yeah. Yeah. The environment has just continued to get worse and worse, and even though they've tried to slow it down, it hasn't done anything to slow it down. So we've sort of failed to keep that from getting worse. But what his story is about is, well, is it going to get so bad that we can't even communicate with others?
That's the real problem.
Yeah. And at first I thought, well, gosh, I don't think it'll ever get that bad. And then I started looking at some of the things that we had done. For example, at one time one of the projects was to send space needles into space, into orbit, and the goal was to put enough space needles up there to reflect a signal off of the needles down to around the other side of the Earth. And that was going to be their communication technique. Well, I thought, that's going to leave a horrible mess behind. At those needles, that's not going to be a stable situation. So that's sort of feeding the possibility that he was talking about. And then there was just other things going on within NASA, like when you start saying, well, where are the satellites that are most likely to run in together? Well, it's mostly in low Earth orbit. But as you go up in altitude, there are fewer and fewer satellites until you finally get to some branches where there's just huge numbers of satellites, and they keep putting more and more of those up, and I began to realize that's just, we're going to have debris raining down on us from higher altitudes for a long time.
The thing that's really fascinating about the needles test in the late 50s, early 60s, they sent like 30 million needles, like a ton, up. And they just, I guess, exploded them into space, expecting them to go to all different directions and then form like a mat to reflect a radio signal. What they didn't expect is that all the needles then slowly came back together and congealed. And that's where I got the concept of static from all the debris. Because what else could be holding the needles together than the static charge? So that's got to be what's happening here. And they're moving at, of course, orbital speeds, which is 17,500 miles an hour. And they're all vibrating and shaking, which we talked about earlier. And that vibration and shaking has got to cause a static charge.
Yeah. I wanted to ask the two of you one more question, then leave a little bit of the suspense for the readers, and then we'll publish some information about the two of you. For you, Mr. Kessler, if you wanted to give an advice for young engineers aspiring to work at NASA or in the space industry, what advice would you give them about tackling, long-term issues like orbital sustainability? What kind of advice would you give any young aspiring engineers?
Well, I would advise them to continue to go on the path that they are doing now, because they seem to be doing the right things and worrying about, when I retired, I appointed somebody to be to take over what I was doing. He was really sharp, and then when he retired, he appointed somebody to replace him, and that person is even sharper. And he was supposed to only last about 2 years. He's been there about 5 years now. Wow. And last time I talked to him, he is going to the United Nations, getting international support for everything that needs to be done. Mm-hmm. And so I'm very optimistic now that they're on the right path of getting that done.
Would you say he's sharper than a needle?
That's a good one. Thank you so much, Mr. Kessler. It's been a pleasure talking to you. And Chris, one question for you about your story and the book. What should we expect coming from the series? Is it going to be a series with a part 2? Because it is the second edition, it just expands on the first book.
Correct.
Are you going to give us another part of the story?
Yes, I don't want to dwell too much on the story without giving it away, but there will be a third and final book.
Okay, great. And where can people find the book right now?
Yeah, Amazon is the largest book printer and distributor in the world. You can also find more information on my website at ChristopherLeeJones.com, and my email is chris@ChristopherLeeJones.com.
Excellent.
If you want me to answer a specific question or collaborate with Donald on a specific answer.
Excellent. Thank you both of you. Ryan, do you have any questions for them? Just real quick.
Donald, this question is for you. If you could spearhead one new initiative to clean up space today, what would that be and why?
That's really a hard
good question. Yeah.
Because the people that are responsible for that right now have a lot more information than I do. I do not stay in contact with them. In fact, I think the reason I don't, even though I try to get in contact every once in a while, is that they're so busy trying to coordinate other things to get them done. And I think they're moved to the United Nations and making sure that everybody is in tune with what's going on. Is probably one of the better things that you can do. And then you use that information to come up with the best guidelines and rules for the road. We've always tried to have our own rules for the road, but we were a small group, and the things have gotten more complicated. There are new issues that need to be addressed. The IAC also had a big conference where the whole subject was how to do something about debris.
What's the coolest thing about space debris that most people don't realize? The craziest thing that's up there flying around? You guys mentioned needles, which is kind of crazy. Is there anything else you can think of that most people might not think is up there floating around?
There's a bunch of tools from the International Space Station.
Mm-hmm. So. I heard that before, actual tweezers and screwdrivers and things like that.
That's exactly what happened.
Yeah, in the movie Gravity, that was one of the first scenes they had. The thing started drifting away. Oh, get that, could run into it again. And then they went into a thing, it's not going to be traveling very fast, but they said, but on the other side of the Earth, it'll be traveling very fast.
Mm-hmm.
Yeah.
Great.
One of the strange things that damaged the shuttle was a chip of paint. So, I mean, it tells you you wouldn't think that would be, it'd be rather innocuous, but it actually damaged the windshield enough that they had to replace it.
So one more thing, actually, because we didn't cover this, and it should be quick, but this piece here, that thing here, and this thing here are very impressive. And we discussed this off camera, but I want to see if you can provide like a brief description on both.
Okay. Yeah, these are the kind of tests that were frequently conducted within NASA, where they would shoot a pellet about this size, smaller than a BB, and shoot it at a target. And when I retired, they gave me this sample, a mounted one. But it's a really good sample because you can see the size of the BB that was used. And when it hits this thing, this is the type of crater that it makes. And of course, then they cut this in half so they could see it from the side, and then sent that to me as a gift.
But that's crazy. That's like smaller than a pinhead.
Yep.
About the size of a pinhead.
And that was actually tested at the NASA facility?
Yes. Mm-hmm. And of course, in reality, in space, things are traveling about twice as fast as these. So you'd see even more damage than this. And of course, one of the things that's kind of important here is this thing that's coming off of the back. When it hits strong enough, it may not penetrate this thing, but you have a spall that comes off of the back then, and then that spall can go through the cabin, and if you're in a cabin, you can get hit by that, and even though there's no leak. And so that became something else that they need to worry about.
Right. And how about this guy here?
Well, this was something that I did. One of the things that they kept talking about is if you were in the space station and for some reason something hit it, it would make a hole, and all of a sudden all the air would suck out, and the crew would be sucked out with it. And I thought, well, is that realistic? And so I said, well, I have this little thing here. And I said, let's shoot a target at it, and here's the input hole that it made. And then what happens when just a small amount of debris that's involved in that comes out, it makes a huge hole in the back. Right. It just blows, it's the pressure of the event. And of course, any crewman in there would be totally sucked out. And what you need to be afraid of depending upon the circumstances.
Excellent.
And of course you can solve this problem by putting multi-layers on here to make sure that nothing even gets through it, so that you never get anything coming over here. Right. And that's of course was a large part of what they had to do with our space stations.
And part of the issue with this as well is if you get hit with this spall, it'd be like getting hit by like shrapnel.
Yep. Okay. Oh yeah, you would not survive a hit like that. Even if it hit you in the foot, your space station would.
Right.
You'd lose your foot, and all the pressure would escape from you.
How do you clean up blood in zero debris?
Yeah.
In zero orbit.
I just want to ask one more thing.
Sure.
And it's to either one of you, but pretty soon they're going to deorbit the International Space Station. Is there any concerns, big concerns that you have? Is there something that you could foresee that could go terribly wrong with that? If so, what would it be?
Yeah. It could go terribly wrong in the sense that either if you don't get the crew out of it, of course, obviously, then something's wrong. But even when that re-enters, you have to carefully ensure that what they usually aim for is to make sure it lands in the ocean. And the first time they ever deorbited anything, they didn't make that calculation, yeah, and it ended up hitting the land and doing some damage. So there's an awful lot of safety factors that they have to go through before they deorbit. And of course, the first one is to get the crew out.
You talking about Space Lab?
Yes.
Space Lab landed in Australia.
Scary stuff.
Yeah.
Yeah. So something else that you never hear about on TV or on the radio, but I haven't heard anybody talk about how much money it costs to get the ISS up there in the first place. We can't even replace it now. We don't have the technology today because the shuttle's gone. Mm-hmm. So you have to kind of turn around, look at it and go, okay, maybe it needs work, but how many billions of dollars did it cost to put it there in the first place? And can we perhaps retrograde it or get it, give it, makeover or something. Perhaps we can work on it in space instead of having just throw the whole thing away, because it costs a lot of money to get there.
It's going to be a lot of work. Only time will tell, right?
Yeah.
Right. It doesn't have to be occupied while they're doing the work, though.
Yeah.
One thing I'd add, the shuttle itself, when they first came out with that concept, I thought that was brilliant. It actually flies. Well, it had so many factors in it that were unsafe. First of all, they didn't even really understand when something hits it. You have this shielding on the shuttle to put during the launch to withstand the heat pressure just going through the atmosphere. Yeah. Well, all that stuff in a lot of cases would just come off during launch, and when you lose that, you lose a lot of the protections of coming in, and that's exactly what happened with that one shuttle. It just did not. I was listening into the crew when they first started re-entering. And
the Columbia?
The Columbia, yeah, and we knew that the left wing had been hit, and the crew, and I listened carefully, and one of the things that you don't even see on TV is the crew. They said, first they said, yeah, we're doing fine, and they said, oh, I'm getting a little bit of heat in our left wing, and they said, but I can take care of that, and then a little bit later, well, that seems to be getting worse. And then just eventually you lose communication with them, and because the wing came off, and they re-entered, killing all the crew. Mm-hmm. So the shuttle, it failed in a lot of ways, and so a vehicle like that just doesn't work very well.
No, incredible.
But it was great at hauling cargo because it had large cargo capacity.
Mm-hmm. Yeah.
Right,
yeah, once you got into orbit, it was a very useful tool, but getting it in and out of orbit, that's the problem.
Yep. And imagine the wing was damaged by foam.
Yep.
Well, thank you guys so much for your time, Mr. Kessler. It's been an honor to talk to you. And Chris, my friend, thank you so much for writing the book.
Thanks for all your help, Rafael.
Absolutely.
I appreciate it.
Have a good day, guys.
You too.
Thank you.